relate to some studies that were released by the International Energy Agency. And if we look at the latest studies that they have put together, let's take the one that was, for example, released on January 2024, which is not that long ago. By that time, they said that with a very fair certainty, they would consider that back in 2022, the global consumption of data center, including, by the way, AI applications and cryptocurrencies, would account for close to 460 terawatt hour of energy, okay, over the year. So that's the starting point. And from that starting point, they made some forecast. And if we look at the forecast they made, the result would be that by 2030, we would need an extra 900 terawatt hour. Just to illustrate the point, the consumption of 460 terawatt hour is about the consumption of a country like France for all usages. So having an increase of 900 terawatt hour by 2030 would mean that you almost need to cover twice the size of France for additional needs on the data center demand. That was in January 2024. And then back in October 2024, they revised their numbers. And they came up with some very different numbers. And they said roughly the order of magnitude of the growth would be more in the range of 250 terawatt hour of additional capacity from 2022. Okay, which is really reasonable compared to the first figure. And then eventually what they did this year, they published a very interesting study. And by the way, we had the opportunity as OVHcloud to be the peer reviewer of that document. And they really refined the way they would model artificial intelligence, taking into account miscellaneous factors such as the model training phase, the inference phases, the location where the inference would happen, and so on and so forth. And they kept as well the forecast of the, I would say, the natural growth of the cloud industry. And then they came up with that number, which is 500 terawatt hour of additional energy required by 2030. So you see the bump, 900 terawatt hour, 250, and then ultimately 500 terawatt hour. I think the main message is that today, no one really knows what's going to be the demand. For a fact, the demand is going to be increased. We know for a fact that data center and I would say the AI infrastructure in general would call out for a lot of energy because by nature, the platforms running those services are very energy intensive. But to be completely honest, we don't know where we are leading. And to add some comments on this one, we have some limitation today, some limitation as far as finding connection to the grid for those type of services or finding the power required for those type of services. So there are a lot of limiting factors. And in the meantime, people are progressing a lot on the way to design the models, on the algorithm that they use, on the amount of data they need to crunch to have some accurate results in the end. So a lot of things are happening and it's very difficult to have some trends. So it's correct to say that it's about time to put all the means we have to be more efficient, to deal with this boom of demand, which relates to the forthcoming of the AI applications. So let's start with the basics, I would say. Let's start with the data center infrastructure itself. I think we have to envisage this boom of AI, taking into account the fact that we need to be very efficient as far as the power effectiveness in the data center. So that's the PUE, the power usage effectiveness KPI we are considering here. And the idea is to bring it as close as we can from one. It's really time to adopt massively water cooling technologies. So there are miscellaneous technologies available today. Either you go the route of direct liquid to chip, which is, by the way, something that OVHcloud has been doing for the last 25 years, since inception or almost of when the company was founded. This is super efficient to capture the heat at the source, right inside the servers, and to bring the calories outside of the building. Another option, which is available and which is becoming more and more mature these days, is what we call immersive cooling. Instead of using airflow, to cool down the servers, like you typically do in data centers. You would immerse the servers in oil. It's called a dielectric fluid, non-conductive fluid. And here you can achieve very good results as well, even a bit better than the direct liquid to chip technology, which is always complemented by air cooling for those of the components not being in contact with the closed circuits, closed water circuits. So by going the route of those technologies, which are probably today not spread at the industrial scale, except for, again, players like OVHcloud by design, I think it's a reasonable lever to activate to be very efficient as far as the power usage. That's number one. Then it's all about the type of AI algorithm you consider. A lot of software developers today are calling out for some, I would say, less demanding workloads for AI, and they have proven. I mean, if you look, for example, at DeepSeek, they claim that they trained their model using a lot of creativity in the way they would run the algorithm, and they claim that they trained their model using far less infrastructure, physical infrastructure. So there is a great deal of improvement to be considered on the software side, and obviously in that chain, let's not forget about the chipset manufacturer. And if you look at the people like NVIDIA or AMD, they strictly follow the Kume's law, and the chipset that they are releasing on the market these days are way better in terms of performance than the ones that they have released a year ago or so. So they keep on with that pace of improvement at the hardware level. And you see, it's really about having all those type of improvement all across the value chain at the infrastructure level, at the hardware level, and at the software level as well. And they are complementary. And ultimately, obviously, that's the usage the people would do from AI. And the frugality will come as well from the governance that the end user will consider in not going the route of AI for the sake of it, but having really some objectives, some needs, choosing the right model, training the models with the right data set in the right location. For example, if you're not sensitive to data residency, you're better off training your model in countries with a very low carbon energy mix, like France or Canada, for example, rather than train them in Poland or in India. It's just common sense. So, all these type of actions will really mitigate the impact on the environment of this new technology. It's very interesting because I saw that the little debate: should we be polite or shouldn't we be polite when interacting with AI? It's a fascinating debate, right? But before we consider that debate, there was another debate, which was what is the energy consumed by let's say a request, a generic request on OpenAI compared to the same type of interaction with a search engine like Google. And not so long ago, there was some studies saying that if you do a standard request in a search engine like Google, for example, you would need a 0.3 watt hour of energy. And to get the very same result using ChatGPT and having a typical 5 to 6 or 5 to 10, I would say, prompts interacting with it, you would then require 10 times that energy. And so that was the basis to discuss the stuff by that time. But it looks like the calculations are wrong. So again, it's fair to say that today no one really knows what is the real energy consumption of AI. And again, it's because of the lack of transparency of the people running the models and training the model in the first place. This will come with time. I'm really confident that transparency will be a common rule among the industry. But the point is, I mean, as long as you don't have the accurate data and you don't measure properly things, it's very difficult to debate or to arbitrate. But again, let's talk about common sense. Why would you use ChatGPT or big stuff like that when you can easily find the result of your search using a different method? That's just common sense. Why would you train again a model with a large set of data when you know that maybe with 10 times less data, you would get the same accuracy in the end? What about going the route of what we called distillated models, which are models derived from large language models, highly specialized models, very specific to some tasks, very efficient in doing some types of calculation? I mean, this is again common sense. This is really a fit-to-purpose approach. Pretty much what you do when you choose the right tool to do something. It's exactly the same approach you need. And again, a bit of frugality, because the dream of putting AI everywhere, the big question behind it is why? What for? What is the objective in the end? The message would be pretty standard. It would be pretty much the same message I would give in their journey and to the cloud, in their move to cloud strategy. I think the first step, number one, is really to consider the environmental credentials of the companies that they want to use. Okay, I think it's very important to select the providers depending upon their ability to prove with truthfulness and real figures and solid data that they do what they can to mitigate the impact of their cloud services on the environment. I think that's number one. It's really to qualify the players among each other and to select the ones which are better in terms of sustainability. That's number one. Number two, I think it's very important, talking about IT applications, talking about IT architecture, that they try to really figure out what's going to be the impact on the environment of their project. And for this one, there are some calculators available on the market, what we call carbon calculators or environmental footprint calculators. And by the way, I made a keynote session at the Open Compute Project regional summit in Dublin last week, dedicated to this, because I really wanted to drag the audience on the idea that we have to align in terms of methodologies to make sure that those tools moving forward, they would converge and they would give the same results. Otherwise, you're not able to compare apple with apples. So it's all about methodology, accuracy of the data, and completeness of the tools. So let's consider that those tools moving forward would be reliable, would be accurate. I think the end users should be using this type of tools to really assess what's going to be the future or the past impact of their services, of the services they are using on the environment. That's number two. And number three, pretty much like today, you have a financial governance in all companies where you have some budgets in terms of capital expenditure or operational expenditure. I think it's about time to set some guidelines to the IT project with some budget as far as the impact on the environment, starting with the mother of all the battles, which is the climate change, meaning they have to limit the CO2 equivalent, the greenhouse gas emissions of their project. That would be a good start. Maybe it would be interesting for those of you willing to deep dive in the methodologies of the tools I was mentioning, the carbon calculation tools. The methodology we have put together a year and a half ago for OVHcloud services is public. It's available on our corporate website. So please check it out. It's a good illustration of how you can go from I would say a classical GHG protocol accounting at the corporate level and derive it at the cloud service levels, and having what we call life cycle analysis, which is the one that makes sense at the service level. So it's a good way for people to really get knowledgeable as far as all the emissions factors that should be considered in order to have a good view on the real impact of the services on the environment, at least on the carbon side of things. But obviously, there are other type of impacts. It's a multi-criteria story that we consider here. And you have the water usage, you have the abiotic resources, the minerals usage. But I think let's start with the carbon, which is a good way as well to arbitrate.